Okay, ladies and gentlemen, here we go. We have discussed now that we use the law of sines to find missing sides and angles if we do not have our 90-degree or right triangle. We've also discussed that depending on what three pieces of information we're given, depends on whether we know we'll only get one answer with the law of sines or we may get more. If you are given information that makes the ASS pattern or SSA pattern, you're given an angle and two sides. Beware. That means when we do our mathematical work with the law of sines, we may get more than one answer. So let me show you this. First example in the notes for 7.2 says, solve the triangle given this information. So first of all, if you look at this information, you're given two sides and an angle. You know if the only angle you know is 30 degrees, we can't assume this is a right triangle. So we will just, for the sake of fun, draw an acute triangle. We'll label angle A 30 degrees. This would be side A. We know that's 7. It doesn't matter who you label B or C. That's how I'm going to label it. This is side C. It's 12. Side C is across from angle C. We look at this picture. We know an angle is side to side. This is the ASS pattern, or we like to write it on paper as SSA to be polite. When we have this pattern, we know we're going to have to use law of sines to find the missing parts. Okay, remember, even though we know two sides, we can't use Pythagorean theorem. Why can't we do a squared plus b squared equals c squared? Because this is not a right triangle. So the only way to find this missing side is to do law of sines. Okay? The only way to find these missing angles is to do law of sines. That's all we have right now in our arsenal to find sides and angles of triangles that are not right. Okay, first of all, if we're going to do law of sines, we have to set up two fractions. The first fraction has to be the information that's given. We have to know a side and an angle that go together. Well, it's obvious. The only side and angle we have here are the A's. So when we set this up, we're going to start with A over sine A. The second fraction has to be what we want to find. Well, we can't have missing both the side and the angle. We have to know one of them. Well, we know side C, so we might as well set up the fraction with C, because we know side C, we can find angle C. We can't use the B's right now because we know nothing about them. We don't know the side, we don't know the angle. So we will use the C's. So to me, that's probably the hardest part, is setting up which two fractions. Let's substitute. Side A is 7. Angle A is 30 degrees. Side C is 12. Angle C, we don't have a clue. Now look at me. In the last section, when we used law of sines, we found a missing side. This is the first time we're going to find a missing angle using this rule. That is why the SSA pattern you have to be aware of. Okay? We're going to do the same thing we did a minute ago. We're going to cross multiply. This is our unknown, so I want it on the left. So I'm going to write 7 sine C equals 12 sine 30 degrees. We are trying to solve for C. So I would move 7 by dividing. Sine of C equals 12 sine 30 degrees divided by 7. Now here comes the boo-boo. I know what you all want to do. You all want to get C by itself, so you think you're going to come on this board and just divide by SIN. We've discussed this since we started trigonometry. Can you separate that trig word and that angle? No, you cannot. So you have to think about what we previously learned. We're trying to find a missing angle. Okay? Back in section 2.3, to find a missing angle, the first thing we did was convert the right side into a decimal number. So now we're going to need our calculator. So let's go to our calculator and type 12 sine 30 divided by 7. It doesn't matter which calculator I use, as long as I am in what mode? degrees. So I'm going to type 12 sine 30, close it, divided by 7. I'm going to do it on the Pro just to prove to you. 12 sine 30, close it. You have to close the angle, divided by 7. Everybody cool with that? Awesome. I'm going to take this one with me to write it on the board. So I'm going to write that whole decimal out. You do not round it or cut it off. Now, who's going to be my brilliant person and remember? How do you use the calculator to give you out an angle? To get the angle C, we have to use sine, but we don't want to use SIN. We got to use the inverse of it. So we are going to type into the calculator sine inverse of this decimal. Remember, we talked about this? The sine inverse button means I give you a number, the calculator spits out an angle. So we write it on paper, that's what we write. Angle C is going to be the sine inverse of that decimal. So now let's go to the calculator and do that. Okay? On the Pro, to get the sine inverse, all we do is double click on sine till the inverse button comes up, and then we type in that decimal. And close it and hit equals. And we know that angle is in decimal degrees because we're in degree mode. On the 30, to get that inverse button, we have to do blue, second sine. We type the same decimal. Hit equals. We get the same thing out. Y'all see that? So that's the hard part. It's the first thing that's confusing. You're trying to find big C. Big C is an angle. The only way to get an angle out of the calculator is to do the inverse, second sine. Everybody cool? Now, this angle obviously is in decimal degrees. We're in degree mode and it's a decimal. You'll have to read your directions and see what they want you to round to. I think this one said round to the nearest whole number. So if we round this to the nearest whole number, do you agree this is approximately 59 degrees? Now you're going to say to me, well, Miss Black, this only gave out one answer. What are you talking about making more than one triangle? All right, here's where everything ties in. You remember when we learned way back when? This little cheat sheet, all students take calculus. What was that for? That told you what quadrant each trig function is positive in. It told you in quadrant 1, all 6 trig functions would have positive fraction values. Well, aren't fractions and decimals the same? So everybody look here. You see this? This is a number. That number is what? It's positive. When I type a positive number in for sine, I should get an angle in which quadrant? Well, I should get an angle in quadrant 1, right? But I also should get an angle in what quadrant? 2. Here's the problem with your calculators. They're not very smart. A calculator can only spit you out one answer. It's always programmed to spit you out the angle in quadrant 1. Okay, that's how it's programmed. When you use your calculator to ask for an angle measurement for trig, and you do the sine inverse and you say, give me an angle. If this decimal is positive, the calculator is programmed only to give the angle in quadrant 1. You've got to know, hey, wait a minute. This decimal value is positive. That triangle should have been drawn in quadrant 2. And to get that angle measurement in quadrant 2, you got to remember the reference angle rules. And the reference angle rule in quadrant 2 was 180 minus theta. So when you do law of sines and you find an angle first, you're always going to take this angle measurement and subtract it from 180 to get the other angle. So if I say, okay, 180 minus 59 degrees, this angle could have also been 121 degrees. Because if I draw the angle 59 degrees and drop my perpendicular, you're right, the sine value would be positive because the y value would be positive, the r value would be positive. But if I drew the angle 121 degrees and dropped my perpendicular and made my right triangle, and I did the sine value, y is positive here in quadrant 2, r is positive here in quadrant 2. So the moral of the story is, when you have the SSA pattern, the bad word, and you are using law of sines, when you have this pattern, you're always finding a missing angle. You got two sides, you got to be finding the other angle. When you find that other angle, take it, subtract it from 180. Now, does this guarantee these are both going to be the angles? No. So you're going to say, how do I prove which of these are right? Or are both of these right? Well, the book tells you to memorize all these rules. Forget that. Let's make it visual. I'll show you how to prove if these are both right. Let's go back to our original triangle. You know in the original triangle, this angle is 30 degrees. It's not going to change. You just found out angle C could be 59. Now you tell me, guys, does this make sense? Could you have a triangle that is a 30-degree angle and a 59-degree angle and still have enough to make the third angle? Sure you could. And what you'll notice is, and I'm going to draw the picture here, if angle A was told was 30, and you just found out angle C is 59, 30 plus 59 is 89 degrees. Three angles in a triangle add up to what? 180. So if I take that 180 and I subtract the 30 and the 59, that gives me this angle's 91 degrees. And that triangle can exist. Now that's 91 degrees, so it can't be acute. It's not to be obtuse. So let me draw that correctly. So we have an obtuse triangle here. Because that's going to be 30. Angle C you said was 59. And angle B just found out is to be 91. So far so good? So that does, when angle C is 59, we do form a triangle. Now you're going to say, well, what about this? Let's do it again. We know angle A is 30. It's not changing. But now we want to know, can angle C be 121 degrees? Well, if you have 30 degrees and 121 degrees, that only makes 151 degrees. There is still another room to make another angle. So that also could be a possibility. So that is another obtuse triangle. Angle A is 30. Oh, I did that wrong. All right. Angle A is 30, but angle C is obtuse. It's 121, which means if you add that up, that'd be 151. So this has got to be 29 degrees, which means both of these work. So with this information, angle A 30, this side 12, and this side 7, you can make two different triangles. They both work. Don't memorize the formulas in the book. They don't make any sense. How do you tell if both of these are the right answers? Put them in the original triangle and see if it works. Okay? Now, here's the problem. The directions on this say, solve the triangle. Well, you're not done. Solve means to find all the missing parts. You know in all these triangles, angle A is 30. That's not changing. You know from A to B is 12. That's not changing because it was given. You know side C was 7. Okay? So we have, oh, I have my side. Yes, side C is 12. I got that. And side A is 7. Side A is 7. Side A is 7. So right now, what we have found is we know two sides, and we found all three angles. We have two sides. We found all three angles. Are either one of these triangles right triangles? No. Don't tell me 91 degrees is right. It's not. So to find this third side B, can we do Pythagorean theorem? Nope. Can we use SOHCAHTOA? Nope. We got to use what law? Law of sines. So we're going to set up law of sines. Okay? Now, let me ask you a question. When we go to set up law of sines to find side B, Okay? What fraction do you want to use? You know you have to do b over sine b. You don't have a choice. Would you do the a's or would you do the c's? If it was me, I would do the a's because I was given a was 30 degrees and I was given side a is 7. I know that is correct. And that's what I'm going to set up. 7 over sine 30. Okay? You all with me on that? Angle B is 91 degrees in this picture. But in this picture, angle B is only 29 degrees. So when I go over here to solve, I would make angle B 29 degrees. I'd still leave side A and angle A. And then we're back to what we learned the other day. To do law of sines, you just cross multiply. So if I cross multiply, B times the sine of 30 equals 7 times the sine of 91. To solve for B, we would divide by sine 30. Finding B is finding a side. We're going to go type that in our calculator. So right now I have the Pro up. It doesn't matter which calculator. They all work the same for this. So I would type 7 sine 91 divided by sine 30. And there is my side B. Okay? Is everybody with me? All right, and then you'd have to read what it wants to round to. In your notes, I think it said round to the nearest tenth. So if I look at that decimal for side B, if I'm rounding to the nearest tenth, the 9 has a 9 behind it, so this would go up to 10, but I put a 0, carry 1. So this is approximately 14.0 centimeters. Now, everybody look. This is a totally different triangle. Even though we have angle 30 the same and we have the side being 12 and the side being 7, these two angles are different, which means this side is not going to be 14 centimeters. So again, to find side B, we're going to do law of sines. This is not a right triangle. Cannot do Pythagorean theorem. So I did B over the sine of 29 equals 7 over the sine of 30. I'm using this because it was given. I'm going to cross multiply. B sine 30 degrees equals 7 sine 29 degrees. I'm going to divide by sine of 30 degrees. So we're going to go to our calculator. We're going to do 7 sine of 29 degrees divided by sine of 30. Okay? So I'm going to type that in. 7 sine 29, close the degrees, divided by sine of 30. Here comes that decimal. Okay? So that decimal is 6.78. It says to round to the nearest tenth. 7 is in the tenths place. There's an 8 behind it. That would round up to approximately 6.8 centimeters. So I want to show you something. I want to make sure we're always relating things back to geometry. I should be able to look and think that my answers make sense because the rule in geometry is the smallest angle is across from the smallest side. The biggest angle is across from the biggest side. Who here is the smallest angle? 30. It is across from the smallest side, 7. Who here is the biggest angle? 91. It's across from the biggest side, 14. That makes sense. If we go to this triangle, the smallest angle is 29 now. It's across from 6.8, which is the smallest side. The largest angle is 121, and it is across from the biggest side. So, when we have the ASS pattern, the bad word, I'm just telling you, you're always going to find a missing angle first. Because if you know two sides, you'll be finding the other angle. When you find that other angle, you must always have two answers. The problem is, how many answers does the calculator give you? 1. Why are we getting two answers again? Understand this. This is a decimal, which was a fraction. When the fraction value of sine is a positive number, it means the triangle could be drawn in quadrant 1 or quadrant 2. Sine is positive in both these. The calculator, when you ask it to do sine inverse to give you an angle, is programmed only to give you the angle in quadrant 1. You have to get the angle in quadrant 2 by subtracting from 180. Now, let me show you an example in your notes where you will not get the two triangles. Okay? I'm not always saying you're going to, when you get ASS, you're going to have two triangles. So let's look at example 2. Okay. All right. Example 2 says, solve the triangle. You're given A is 4, C is 12, and angle A is 30 degrees. I know, Miss Black is boring. She keeps using 30 degrees. All right. If you look, you have an angle and two sides. The only way if I know this is the ASS pattern is I have to draw the picture. I hear nothing about a right triangle, so I'm just going to draw an acute triangle. A, B, C. Angle A is 30. Side A is 4. Side C is 12. If you look and I look at this, this is angle, side, side. This is side, side, angle. If I go in a circular motion, this is the bad word pattern. That just gives me a head up. Hey, when you start doing your work, you may get more than one answer. Or you may get the opposite, no answer at all. When you have the ASS pattern, you have two sides, you only have one angle. So it makes sense you're going to find another angle. Don't tell me you're going to rock and roll Pythagorean theorem right now. Is this a right triangle? No. You cannot do A squared plus B squared equals C squared. So this is not a right triangle. We can't use SOHCAHTOA. We can't use Pythagorean theorem. We have to use law of sines. Okay. Law of sines. First fraction. What do we know about the side and angle for? The A's. So I'm going to write 4 over the sine of 30 degrees. That's the A's. Your call. What would you like to find now? Side B, angle B, side C. Well, can we do the B's? No. I don't know side B, and I don't know angle B, so I can't even set up that fraction. So it obviously has to be the C's. I know side C is 12. I don't know angle C. All right? That's my setup. I'm going to cross multiply. This is my unknown. I want it on the left. So 4 sine C equals 12 sine 30 degrees. I'm trying to get C by itself. Let's move the 4 by division. This is as far as you can go on paper. You need a calculator now. To find an angle, you got to convert this in fraction into a decimal and then do second sign. So let's go to our calculator. All right, walk with me over here. All right, clear these out. All right, so I'm going to type 12 sine 30, close that, divided by 4. There's my decimal, 1 5/10. I'm going to do it on the 30. 12 sine 30 divided by 4. Same decimal. You'll agree? So now what I'm going to write is the sine of angle C is 1 5/10. You cannot take that word and move it away from that angle. They are stuck together like glue, husband and wife. They're handcuffed together. They're not coming apart. You are trying to find angle C. The only way to find angle C is to do the inverse in the calculator. So you would write angle C is going to be sine inverse of 1 5/10. The calculator knows when you do the inverse, you're going to give it a decimal and you want it to do the opposite, spit out an angle. All right, let's go do this. So, on the Pro, I'm just going to double click to get the sine inverse symbol up. I'm going to put my decimal in. I'm going to hit equals. Uh-oh, it gave me an error. Let me try it on the 30. To get the inverses in blue, so I'm going to hit second sign. Put that decimal in. It gave me an error. That error message means this decimal is too big. And if this decimal is too big, we can't get an angle out of it. This is not solvable. We cannot get angle C. Well, sweeties, if we can't get angle C, what that's telling us is if we took our rules and protractors and tried to draw this triangle, it would never make a triangle. If I measured a 30-degree angle and I had to measure this side to be 12, there's no way this side being 4 would close in and cut it. What happens is, if this side has to be 12 and I only can make this side 4, it would never reach. There is no triangle here. So there's nothing to solve for. And again, it's that crazy ASS word, that bad word, that tells me I better beware. Something may go wrong. Okay, we have one more example in our notes. Let's look at the last scenario. All right? So the last scenario, let's see what it gives us. Hold on a minute, please. I lost my place. All right, here it is. Solve the triangle given. A is 15, C is 12, and angle A is again 30 degrees. I apologize for being boring. Okay? All right. Again, given two sides and an angle. Great. Let me first draw it to see what pattern it is. If it was side, angle, side, which we haven't done yet, then we wouldn't even have to worry about any of this stuff. Okay? But if I draw this picture, and I know it can't be right, I don't have any information yet. Angle A is 30, side A is 15, side C is 12. Up, ASS, SSA. That just tells me beware when I use law of sines. Okay, I got to start with law of sines. I can't do SOHCAHTOA. I can't do Pythagorean theorem. Why not? That's right, because it's not a right triangle. So here we go. What do we know? We know side A and angle A. So that's what we're going to start. 15 over the sine of 30 degrees equals. All right, are we going to set up the next fraction for B's or for C's? Well, we can't do B's because we don't know angle B and we don't know side B. Have nothing. So we're going to have to set up the next one to be C's. We know side C is 12 and we don't know angle C. Okay? Cross multiply. That's our unknown, so I want it on the left side. So 15 sine C equals 12 sine 30. I got to get C alone, so I'm going to divide by 15. Sine C equals 12 sine 30 degrees over 15. So now we have no choice but to go to the calculator. To get an angle measurement out, you must change the fraction to a decimal. Here we go. All right. Clear. Clear. So I'm going to hit 12 sine 30, close it, divide it by 15. All right, I get 4/10. I'm going to do it on the other one. 12 sine 30, close it, divide it by 15. All right, both calculators give me 4/10. Wonderful. So now I know the sine of angle C is 4/10. The only way to use your calculator to get out an angle is to go in the opposite direction. Tell your calculator you got to do the opposite. The opposite of sine is the inverse button. So we're going to say angle C is going to be the sine inverse of this decimal, 4/10. Everybody with me? This symbol, this -1, this inverse button means I give you a decimal, you spit me out an angle calculator. Let's go do it. Hopefully we'll get an answer this time. So in the Pro, I double click to get sine inverse. I type in my 4/10. I got an angle, 23 degrees with some other parts. Over here, I do on the 30, second sine to get the inverse. I put my decimal, 4/10. All right, I get the same thing. Everybody good with that? Awesome. So, angle C as decimal degrees is 23 degrees with that long decimal. Now, if you look at this example, it wants the angles in degrees, minutes, seconds. So now, that's not good enough. To just write decimal degrees is not good enough. So let's go back to the calculator. And to refresh our memory, how do you change decimal degrees into degrees, minutes, seconds? you need the DMS button. So on the 30, the DMS button is under your symbol. I arrow over. DMS comes on the screen. There's my angle in degrees, minutes, seconds. On the Pro, my DMS button is under Math. I arrow over to DMS, and then I have to arrow down to number 6. Get it to come on the screen. Did I get the same result? Yes, I did. Everybody's good? Awesome. So now I'm going to go up here and write this. Angle C is 23 degrees, 34 minutes, and 41.4 seconds, which is 41 seconds. Now, I believe on the homework it says to keep this in degrees and minutes. So if we're just going to use degrees and minutes, would 34 minutes stay 34, or would it go up to 35? With around minutes, you have to look at seconds. And you need, if you have at least 30 seconds, that pulls us up a minute. So if we round this, angle C is approximately 23 degrees, 35 minutes. Everybody's good? Okay. But we said a minute ago, every time you do ASS pattern with the law of sines and you get an angle, if you get an angle, it's going to give it to you in what quadrant on the calculator? Quadrant 1. Where else could the sine value been a positive decimal or fraction? In quadrant 2. So now you've got to take this angle and subtract it from 360. So right now you have angle C is approximately 23 degrees, 35 minutes. To get the other angle, that's quadrant 1. There could be an angle in quadrant 2. The calculator just is not programmed to give it to us. We have to subtract this from 180. So let's go back, way back to the beginning of this course. 180 degrees minus 23 degrees, 35 minutes. I have no minutes, so I put my placeholders. I'm going to borrow. That becomes 179 degrees. When I borrow a degree, it makes 60 minutes. I subtract, I get 25 minutes. I subtract, I get 156 degrees. So, a minute ago, when we did example 2, we got an error with the calculator, which meant angle C did not exist at all, and we just stopped working. This time, we got an angle C, and I'm telling you, if you get an angle C, if you get an angle with the ASS pattern, you must go get me the other angle in quadrant 2. Now, the decision is, can both of these really be angle C? The only way to prove it is go back to your original picture. Do not memorize those formulas in the book. That's just too much work. Let's think about this. If angle A is 30 degrees, could angle C be 23 degrees, 35 minutes? Well, if I add these two up, 30 and 23 is 53 degrees. Sure, I can have another angle. That can make a triangle. So this can work. If angle C was this, 156 degrees and 25 minutes, could that work? Can you have in a triangle an angle that's 30 degrees and an angle that's 156 degrees? No way. Because if you add these up, that's 186 degrees. And how many degrees can you only have in a triangle? 180. So that's way too much, which means that can't work. And that's how you decide. Don't memorize those crazy formulas in the book. They make no sense. All you got to do is when you do law of sines and you find an angle, you're always going to get in the calculator the angle in quadrant 1. You physically have to get the angle in quadrant 2. How do you know if we keep them both or we throw them out? We put them in our picture and see if they make sense. 3 angles in a triangle have to add to 180. This is too much. So that cannot be angle C. So now you know, according to this information, there is only one triangle. That's it. There's one. We know for this one triangle, this is angle A. We know angle C now is 23 degrees, 35 minutes. We know these two sides. So now the question is, what do you want to do first? Find side B or angle B? Well, that would be the easiest one to do is find angle B because we could use geometry. These three angles have to add to what, y'all? 180. So if we take angle A, add it to angle B, add it to angle C, that should make 180. We know angle A is 30. We don't know angle B. We know angle C is 23 degrees, 35 minutes. We know that should add to 180. So if we add these two angles up, angle B plus, this would be 30 degrees and 23 degrees is 53 degrees, 35 minutes, equals 180. We know how to do this. We'll subtract. We're going to subtract 53 degrees, 35 minutes from 180. We put our placeholder zeros. We borrow from 180, we make it 179 degrees. That means we really borrowed 60 minutes. So 60 minutes minus 35 minutes is 25 minutes. 179 degrees minus 53 degrees is 126 degrees. So now we know angle B is 126 degrees, 25 minutes. Everybody's good? What's left to solve for? We got to get side B. Oh, that's easy. We'll just do A squared plus B squared equals C squared. No. What kind of triangle is that? Well, it's obtuse because we got a bigger angle bigger than 90. This is not right. No Pythagorean theorem, no SOHCAHTOA. The only way to find side B is to do law of sines again. When we do law of sines again, what fraction are we going to start with first? We're going to use angle A and side A because that was given. We know that's correct. 15 over the sine of 30 degrees. We want to find side B, so now we have to use our angle B. We don't have a choice. Cross multiply. Here's my variable, so I want it on the left. 15 sine 126 degrees, 25 minutes. We're going to divide by sine 30 degrees. B equals. Now we have no choice. We got to use our calculator. So I'm going to sit down. I'm going to type this in. All right. It's just more typing. So we want to type in. I'm going to do it the pro. We want to type 15 sine. We want to put in 126. Now we need the degree symbol. So we go to math, arrow over to DMS, degree symbols highlighted. We want 25. We want minutes. Math, arrow over to DMS, arrow down to minutes. Close it. Divide it by sine 30. That should be side B. Let's do it in the 30 to make sure we get the same thing. Okay? So again, it says 15 sine 126. To get degree, we go to our button here, and it's highlighted. We hit enter. We want 25. We go to that same button. We arrow over to minutes. We hit enter. Close it. Divide it by sine 30. We get the same answer. And I believe in the directions it said to round to the nearest tenth. So that side rounded to the nearest tenth should be 24.1, whatever units this was in. If they didn't give us units, we just write the word units. So that is the hardest thing to understand is using law of sines. When you're using law of sines to find an angle first, you could get two angles that work, one angle that works, or no angles that work. The no angles that work is easy. The calculator gave you an error. Whether you know whether one angle is going to work or two angles are going to work depends on if you do your arithmetic correctly. You always take the angle you get out in quadrant 1, subtract it from 180 to get the angle in quadrant 2, and then put them one by one back in the original triangle and see if that makes sense. It's going to take some time and it's going to take some practice. So go slow and really work on this. Okay, we have one more rule of law to learn that talks about finding sides and angles and missing triangles. So I'll catch you in the next video.